uh, oh, hi, Shannon. Hi, everyone. I'm gonna get us started in a sec. Just getting myself ready. Wait, so then you both are in Garcia? And so he canceled? Yeah. Wow. Are you gonna be able to go home? Yeah. Basically, did you come to see the show? People are doing it?
Well, I can go to, I don't know where to pick up that.
Oh, that's a you can go full hour. And I'm pretty sure they're gonna say, oh, your turn is cool. Very much. That's cool. Get to relax.
Wait, so like, is it possible for Dylan to visit here? No.
I mean, I wouldn't have a problem. Did you try asking Miss Michelle?
I'll ask her like.
She's really cool. I mean, I hope she says yes.
Are you gonna be here tomorrow?
Tomorrow? Yeah, so that we can do the thing, right?
Yeah, no, but like before.
Yeah, I'm gonna just do my PD here. We have like a morning PD, so I'm gonna be here in my room tomorrow.
Oh, so
Feel
can I?
free to say, oh wait, you were earlier before me though.
Oh, you
You are. Your test is at 8 a.m.
are?
and you have to be here like 7:40 or just like sometime before.
Cause I need to leave the cheapest deal.
I mean, if anyone, feel free to tell them. I mean, it's fine. I mean, I can leave my door unlocked. Just drop it in here, and that should be fine.
Okay.
Or remember to unlock it.
Well, I text you. You must take the door.
Okay, thank you. That will help. Hi, everyone. Welcome. Bye. Just getting myself situated. And we're gonna get started. Get my slides. Hope y'all are having a good afternoon. Otherwise, let's see. Okay. So AP Calculus, welcome to day 2. Oh my gosh, so I just put on my earphones, so in case anyone was talking, hello. Welcome to AP Calculus day 2. It is Thursday. We're almost done with this week, so I hope y'all are excited. It's also exciting because, well, most of us are seniors, but it's also exciting. Most of the seniors, you're almost close to graduation. For those who aren't seniors, don't worry. It's almost close to the end of the school for you. So yay. So we all got something to be excited about. So yesterday we started a class with, and let me make sure I'm recording. So I am recording. Awesome. Yesterday we started off with deciding on a risk to take, and hopefully think about the risk that you took yesterday. Maybe you want to take that risk today, but for today's check-in, I actually want to do affirmations. Now, for those who are in my advisory, we usually do some positive affirmations. They really work. They're scientifically proven. But these ones that I put on this list are actually like the learning ones or like math ones. So take a look. For example, I will make mistakes to learn. A lot of times in society, pressure, mistakes are looked down upon, right? Or you put yourself down when you make mistakes, but in reality, we got to make mistakes to learn. So just having that as an affirmation today would be nice if you'd like. I'll see you. Another ones are like my thoughts matter. Like I said, if you're usually the type who withholds sharing your thoughts, that's like me. An affirmation will be my thoughts matter. So take a look at this list. These are different kinds of affirmations, or if you want to bring your own affirmation in here, go ahead. So think of an affirmation you want to hold on to for today's 1 hour class, actually 55-minute class, and let's hold on to it. So I'll give you all some time. I actually see a few things in the chat. Let me open up my attendance thing. And then what's cool about sometimes me as a teacher, when I'm reading some of the affirmations, it's like they become mine as well. Like if I'm having doubts, I remember some stuff that you all say. And it's really nice to kind of have these affirmations. So let's see what y'all are thinking. Let me get in this chat box. Yes, we have I will make mistakes to learn. I love it. I believe in myself. We got number 5. Yay, another I believe in myself. Progress, not perfection. Yes, definitely. Let's focus on progress, not perfection. I can improve my thinking a little by little. We got number 7. I can train my brain. Yes, we could always improve the thinking in our brain. We have another for progress, not perfection. We have a bunch of 4s. Yes, so a lot of 4s on progress, not perfection. And we have a 9. I can improve my thinking little by little. Yay, y'all. Thank you so much for sharing. You know what mine's going to be today? For surely it's going to be the mistakes today because I'm going to try to use the iPad for some math work. And it's always going to be a learning process using all this tech and stuff. So I'm going to for surely be patient with myself. I hope y'all are patient with me too. But all right, thank you all for sharing. I am just looking through who shared in the check-in question. Let me see who I'm missing. I'm missing Kaylin with a C, Fernanda, Roxana, Evie, Sofia Pena, and Gracia. Let me know if you're actually here, and I apologize if I marked you absent. Oh, Evie, I see you there in the list, so you're here. Anyone else that might have been here and marked absent? All right, and if I did announce your friend who might be absent, please let them know to come on into class. I'm gonna take this off because I'm actually alone here today. Close the door. All right, everyone. So thank you so much for sharing an affirmation that you're gonna hold on to. Let's go ahead and use those as motivations for ourselves today. Let's see what we're doing today. So what's today's credit? I entered in yesterday's credit in PowerSchool. If you have any complaints or anything, feel free to message me. I could totally change it. If you want to just go to the Padlet and just answer the Padlet stuff, you're set. Okay, y'all, so what are we doing? I just took attendance. Again, I'm gonna refresh with y'all the mini module expectations and process. Yesterday it was asked if we could talk about, kind of remind ourselves how we're doing the math from mini module number 4. So what we're gonna do is yesterday we looked at that model solution. We're gonna try to break it apart and kind of see how that student got that specific answer using calculus. So we'll review the math a bit. Then hopefully have some time to revise the mini final. There's going to be similarities and differences activity on Padlet. Lastly, we'll have our checkout. So these are the things that we'll be doing today. And how will today's, AP test, some updates, sorry. So I put this in yesterday. A question that came up for many of you was for the school Chromebook. So if you're planning to test on the school Chromebook, on College Board, it had said something about the administrator had already installed something. So I asked Miss B about this, and this is what she said. She says, I believe the school issues Chromebooks have AP testing browser installed, but that y'all should verify this. So those steps that are on the Padlet that I gave you that you have to go through before the test, you want to just make sure you do have whatever browser they're talking about. And then specifically, you could read down here in the second paragraph. So you could check if your Chromebook already has it. You look for an apps button on the bottom left, and if the list of options do pop up, it says secure browser and another one for AP. So if you see this, that means you probably do have it, but you should verify. So always just verify if you have that. Welcome to those that just came in. If you could send me a private message that you're here, that would be awesome. I heard like 2 people come here. Oh, there's a question. And let me fix the attendance. Of course. If we pass the test, how will that benefit us? So yeah, if you pass the test with a 3 or higher, that means you pass it. You get college credit for that class. So it would college credit. You wouldn't have to take that class anymore in college. It also does depend, and feel free to, y'all can jump into office hours. So it does depend on what your major is. And if you're needing to take higher level math, then it'd be great to get this out the way, the calculus class. Some students don't even need to end up taking calculus, depending on the route that you're going for. So sometimes in college, you have the option of going into calculus or the option of instead taking statistics and going into a different route. So it depends as well on you if you're going to be needing calculus. So for example, nurse. I believe nurses do need some higher level math. Nurses would require calculus. So it depends on your major too about the usefulness of getting AP credit. So that's a good question. Some more information. So this is the breakdown of how the test is going to look like. So as you all know, it is digital and it's going to be on June 9. There's a multiple choice part and there is a free response part. So parts where you write down, and there's also multiple choice. Each portion is 50% of your score. So that's basically the breakdown. Biological sciences could perhaps require, I would say yes, most of the sciences do require some upper level math, yes, but not too high. They usually stop up to like calculus 3, which is like part 3 of calculus. Yep, and chem. I mean, if you ask me in my experience, chemistry was a butt kicker for a lot of students for surely because it combines math, so like upper level math with like actual experiments and stuff that you have to do. So I don't know, it was a butt kicker, but you could ask some college students on how their experience was as well. All right, so let me know if there's any questions about AP test updates. Throughout these days, I'll be giving you some more resources that you could use to prepare yourself. Nextly, how are we getting credit today? So we're going to be going back to that revision document and revising our solutions based on looking at that model response. So we got to start on this yesterday. So we're going to try to make sure we get back on it. And again, so many of you were like, what if I didn't start? That's fine. You're just going to get started on it based on what we do today. And then, of course, most of our participation will be responding to all Padlet questions and prompts. That's pretty much it. So that's today's participation. Let me know if anyone has questions. So today's participation credit. So you should see an A pop up if you did all that, if you did these two things here on my slide. All right. As a reminder, things you should have open, big ideas packet, and instead of me saying your mini final, you should have actually already copied and pasted your mini final responses onto the revision document. So these are the two things you should actually now have open. Big ideas packet and your revision document. So let me give you some time to open that up if you haven't yet. I'm also going to go and open big ideas packet too, because I think I'm going to reference it. So let me go and do that. And just a reminder, y'all, your revision form is right here. The other day we spent some time opening it. So if you see your document open here on my screen, that means I have access to it. So I could also comment on the document if I need to kind of relay some information. So again, if you don't see your little window popping up, it means I don't have access to your document. And if for some reason, it could just be a technical thing. If you don't see your box there with your document, if you could just share me your copy on my email. That way I could have a copy of it. We don't have to worry from there. So this is the thing you should also have open as well, because on this document is where we're going to either be starting our mini final or we're going to be revising it. All right, everyone. So let's get ready. Let's get ready to talk about today. Okay, everyone. So let's think back to that model answer we looked at yesterday. Pretty sophisticated work. So how did the model answer exactly find the area of window number 2? There are two waves. Dude, I was teaching waves in calculus. I mean, there are two ways, not two waves. Anyway, there are two ways to, in general, find an area. Maybe there's a different way that's not listening. It's either geometry or calculus. These two different ways were also covered in your big ideas packet. There's using geometry to figure out area, and there's also the calculus route, which is using the fundamental theorem of calculus, specifically part 2. Let me show you once more what this model answer looked like. Oh, I guess we're going to a Padlet. Give me 1 second. We're not on the Padlet just yet. I want to again kind of have us take a look at the model solution right here that we looked at yesterday. So take a look. Let's read the description. They got 2 feet squares and they said, I know because I used the fundamental theorem of calculus to calculate quadrant 1. So there's that integral symbol. They put a 0 and a 1 here at top, and then they put 1 minus x. And if you look back at the problem, the original problem itself, let me open up a copy of the revision form so we could look at the problem itself. And specifically, we're talking about window number 2 right now. The function that was provided for you was y equals 1 minus x. That's representing this black line right here. That's that function. So they're using the function, and they're also using the integral, basically this elongated S symbol. So, and then they have some steps. So we're going to try to break it down and kind of understand how the student got this solution. So once they did that, they either got 1/2, it says, or 0.5. Then what they did is basically this 0.5 only represented basically one triangle. So they had to kind of add up 0.5 or multiply by 4 to get 2 feet squared. So that's what the student did. They also showed the added added version of it right here to get 2 feet squared. So today we're gonna go ahead and talk about this because it was requested. So there was a request to go over how to do this portion. So how do you use calculus to find the area? Oh, there's stuff in the chat. Will the recording of this be on Google Classroom? I could put it on Google Classroom. Well, where would the packet be? And were we only supposed to paste our responses, right? Never mind, I found the packet. Yeah, so the packet's on Google Classroom. And for now, yes, for now we have only copied and pasted. We haven't yet had time to actually revise. I wanted to make sure that we were all understood what we're doing first before we get to revision. So we haven't yet revised unless anyone took some extra time after to do that. All right, let's break it down then, everyone. So how did this particular student get that window number 2, this window here, has an area of 2 feet squared? Okay, these are the 2 things we need. Things we need to understand the model solution that we looked at the other day. One of them is we need to know how to take the antiderivative of a function. So if y'all remember the rule, if you have x to the n, the antiderivative of that is basically x to the n plus 1 divided by n plus 1. Now, when you don't have a lower or upper number on your integral, like this does, usually you put a plus c. But we're not dealing with plus c's here because we actually have exact areas. So just in general, as a reminder, is why this plus c is there. But we will be using this right here, this rule, x to the n plus 1 divided by n plus 1. Another thing we need, in addition to knowing how to find an antiderivative, is we need FTC part 2, the fundamental theorem of calculus part 2. That's this rule. If you all remember, this was the formula. Capital F represents antiderivatives. And after you take the antiderivative, you plug in your upper limit, subtract, and plug in your lower limit, which is here. Then you would have to simplify your answer and you get your stuff. So these are the 2 things we need to understand what that student did in that piece of work. Before I get started and transition to the iPad, does anyone have any questions about the stuff we need or any other thing before I move on to iPad? All right, so I don't see anything popping up for us, but if anything comes up, let me know. So I'm gonna transition to the iPad. Let me just try and see what you all see right now. Let me see how I can view this. Well, I guess I'm gonna have to stop my share. So I'm not exactly sure if I'm spotlighting the other one, if it's gonna be big or small in the recording. So I'm gonna have to stop my share, but even though I'm stopping my share, keep in mind, these are the 2 things we need, so that I don't have to rewrite it on the board. So I'm gonna stop my share. I'm going to, so right now you should be seeing the board being spotlighted. And what's gonna happen is I'm going to go ahead and let me sketch the problem, write down the function, and then we'll go from there, y'all. Give me a moment. Hope y'all can see this. Oh my gosh, it's been a while, everyone. Probably need a ruler. Is that correct? Was it at 1? Double checking, or was it at 0.5? I'm going back to window number 2 to make sure. Yeah, they were all at 1, and the function was y equals 1 minus x. So that's just me looking back at the mini file. Okay, so there is the picture. And we know that this function right here, actually, switch and color code, this function in green is only being represented by this portion. That's what we know. We also have that this is 0. The origin is basically 0. So we have this information. Okay, cool. So how are we going to apply basically antiderivatives and the fundamental theorem of calculus? How did the student do it? So one thing I noticed is the model solution did this. They set up the integral like this. They said the integral from 0 to 1. Now, as a reminder, everyone, if you look at your big ideas packet, I hope you all can hear me well. If not, let me know. Let me see if there's anything in the chat. Okay, I don't see anything yet, so I hope you all can hear me. The model solution set up from 0 to 1, and if you remember, y'all, the integral means find the area under. This little elongated S, find area under curve or line. I'll just put curve. We usually call it a curve. And it's saying from 0 to 1. The 0 to 1 right here is representing the x-axis. So from 0 to 1, the area under the curve, this is how we shade that portion. When it comes to calculus, everyone, when we say area under the curve, we mean under the curve and it stops at the x-axis. We don't go below that. So I hope y'all can see that. Not my face. This. So that student that set up the integral, this is what they were finding. The area of the part, I color coded in green. Now what usually goes after your integral is the function. So that's why they wrote 1 minus x. And then due to notation requirements, we always put dx after our integral. So that's just the reasoning behind how the student has set up this solution for model number 2. Now comes the math part. Now comes the part where we have to know how to take an antiderivative and also apply fundamental theorem part 2. So let's do this. So another connection that the symbol also tells us, it also represents taking an antiderivative. So there's kind of like a double meaning here, but it's connected to area. Also means antiderivative. Yeah, I had to just shorthand that. So we need to take the antiderivative of 1, and we need to take the antiderivative of x. So how we're going to take the antiderivative, everyone, is basically, oh, I see Rosa, you did a comment. Is it 1x minus x squared? That is very close, Rosa. The antiderivative is almost that you wrote down in the chat. That is so close. How do we take the antiderivative? So just to remind you all, on our slides today, I wrote down the antiderivative rule. Basically, where should I write this at that has space? I'm gonna write it right here. So remember, it was in our slide. This is what it looks like. In our slide, there's that plus c. We're not gonna worry about plus c though. So this is what we're gonna use to find the antiderivative. Now notice for us to use this, it has to be x to some power. This x is gonna be to the power of 1. 1 though, we can imagine that 1 is like x to the 0 power. Because anything to the 0 power is 1, and that way we could use this rule. Let's see if there's questions before I get started and start taking the antiderivative using this rule. Oh, let's see, there's. Yay, that's awesome that you're getting the hang of it again. All right, so let's try this. Let's do this. So this is x to the 0. To get the antiderivative, I'm going to do x to the 0 plus 1 divided by 0 plus 1. Let's just write it out. That's the antiderivative of this one here. I'm going to bring down the minus. And right here, we're going to do x to the 1 plus 1 divided by 1 plus 1. So that's just me right now using this rule. I am finding the antiderivative. Now let's go ahead and simplify that. So x to the 0 plus 1, that's just x to the first power divided by 1 minus x to the second power divided by 2. So Russell, you were super close. X to the first power is just x, y'all. And if you divide it by 1, that's still just x. So essentially, we can rewrite this as just x. So basically, it was just the divided by 2 that was missing there. You can keep it like this. I know when I keep pulling out as 1/2, a lot of students get confused. So this is our antiderivative. Let's just keep it like that. So this is simplified. So right now we have just done the antiderivative. Cool. We're not done yet, right? Because what we need right now is the fundamental theorem of calculus. Fundamental theorem, I'm going to write it down here. I hope y'all can see it. Fundamental theorem says if I want to take or if I want to find the area under some function from a to b on the x-axis, I'm going to take the antiderivative, capital F. I'm going to plug in b, the upper b, subtract, again, antiderivative, but this time I'm going to plug in a, that lower number. So that's what we're going to do next. So we're going to plug into this right here, which is our antiderivative. This right here is capital F. That is where that capital F is. That's what we just did. So let's do this. The upper number is 1, so we're going to first plug in 1. And I'm going to use brackets. I hate that I'm really close to this side. By the way, if anyone spots errors, please let me know. Because you know I'm prone to doing that. So I plug in 1 into the antiderivative. Now I'm going to plug in 0. Yeah, this one's a little bit too close to my work. I think I can fit it though. Okay, next what we're going to do is we're going to go ahead and simplify this. So 1 minus 1, so 1 squared is basically 1. So 1 minus 1/2, that's simply 1/2 right here. Minus, and I hope I get the same answer that the student got. Oh gosh. Then we got 0 minus 0 squared divided by 2. Y'all, that just becomes 0. So 1/2 minus 0. I got 1/2, aka 0.5. So I did get the same solution. So 1/2 represents the area of one sliver or one triangle. So that means the area of this total window is, if you, like the model student solution says, add these all up, or 0.5 times 4, you're going to get that the overall area is 2 feet squared. These again were the formulas I used to not confuse you in my board work. Like I said, it's been a while, so I kind of overlap some stuff here. There's the formulas, there's the work. Let's see if there's any questions. I don't see any questions in the chat. So that is the understanding to that model solution, so with a little explanation there. And also, hopefully it was a refresher for some of you. Okay, let me go ahead and transition back to my laptop. Oh, the question is, wait, why is it squared? Let's see. Oh, you mean why is the feet squared? Because area is usually in square units. That's the why. So for example, if you find the area of a box, and it was like, this was 2 feet, and then this was 2 feet, and you multiply the two, you know that you're gonna get an area of 4, but feet times feet is squared. So area is always squared. I hope you could see that. It's a little faint in green right there. So that's why our answer, the units and feet, is going to be squared. Good question. I hope that answered the question. Oh, yeah, you can go to the bathroom. I didn't see that. Yes. Okay, so I don't see any more questions coming up. So I'm going to go ahead and take the spotlight off the video, off the, no, I'm going to keep it there actually. And I'm going to go ahead and share my screen. So we have now kind of broken down how that student with the model solution got 0.5. The same stuff and the same process that they did, I went ahead and on the board broke it down for us so that we could understand where it all came from, and also so we could get a refresher. So that is how we got the solution. Alternatively, hopefully we could see later on in these days how somebody could get the same answer using geometry. So geometry was also an option here. You could have broken this up into triangles or square, things like that. So let's go to our slides. And this is what we're going to do next, everyone. Now we're going to go ahead, since we now have a little understanding as to how that model solution got their answer, we're going to open up that revision document on Google Classroom, and we're going to work on revising window number 2 or any other windows if you still need to work on that. For those of you who did not get started on mini final, go ahead and start typing out, writing out a solution that works for you. You just want to actually give a verbal explanation. You could also refer to the Padlet from yesterday. Let me make sure you all get the Padlet. I know I kind of opened it twice. So what do I mean about the feedback y'all gave? I mean this. Y'all gave feedback for the model solution. You gave positive feedback. I mean, kind of like props. Like, wow, their solution was really cool, this and that. And then you also gave some critique and feedback to a different solution, right? You could look here. So you're gonna combine, basically take a look at columns 3 and 4 on the Padlet, and you're gonna try to revise your work for the second window, because we only talked about window number 2. Later on, so hopefully today we'll talk about window number 5. We're gonna be doing similarities and differences, but that's after. What if you got them all right or get advanced? How will we revise? So if you already got advanced and you feel like your revision addresses all this feedback, then you are fine and you're just using these next 6 minutes to chill, basically. Good question. But don't worry, we're gonna need you for when it's time for peer feedback and stuff. If you feel like your stuff meets all of this, then you're set. Yes. Okay. So let me guide everyone though, so that we all know where we're at. So our revisions are happening on revision form. This one right here, the one we looked at the other day. So this is where you're going to be doing your revisions. But before you start, you need to copy and paste your original responses on this document so you can start revising. Now, I don't know if anyone has done that yet, so I could give an example of what this should look like. That even if you got advanced, you're also gonna copy and paste your stuff over. And again, for those who didn't start, you're gonna start right on this document. We just talked about the solution for number 2. Now it's your job to kind of explain it to us, and you could give your version of the solution here. Great, so I can see right here. So take a look. So this is Edgar's copy. As you can see, Edgar copied and pasted his work from the mini final onto this document. So it's on here. So now what Edgar's gonna do is just go back and kind of just make sure his work is clear, make sure he addressed all feedback. If it feels like it's good, then it's good. So that's what we're gonna be doing. We're gonna be revising on this here document. Are there any questions? Does anyone have questions before we start? And we'll have like 6 minutes to kind of copy, paste, and revise if we need to. Question is, will I go over with the other problems with this too, because this really helped me understand. Well, today the intention was, let's see, I'm gonna be going over window 5. So we will be going over a few more, yes. I'm glad that it helped. That's the main essence and the main importance. So we'll see, and if there's more requests, feel free to let me know. Yeah, because then we'll meet next week and I can make time for it. All right, awesome. So I'm gonna put the directions of what we should be doing in the next 6 minutes into the chat. And then we'll come back in 6 minutes. Here's the directions. I apologize. I had the caps lock on, but there we go. I'll start at 6 minutes, and if anyone has any questions, just send me a direct message. I'll be right here. Yay. Okay, I'll be back. All right, everyone, welcome back. So I hope in the 6 minutes that you had, so you either got started if you didn't on the mini final, or you did some revisions to make sure your solution is clear to your peers. And if you felt like you did great, feel free, to look over your work. Maybe think about how you would help a peer later on when we have like feedback sessions. So, y'all, I'm gonna take us back to our slides. So yeah, I'm also hoping we get more submissions, which is gonna be cool. Oh yeah, back to our slides and let us go on to the next window piece. Window number 5. Now this window is really interesting because it has an E first off, has an E for base. Now E is like pi, it represents a number. I have two different solutions for you. So two students that did it a different way, they also got different solutions. And we're gonna try and see, what we can gain from taking a look at this activity. So you're gonna take a look. It's gonna be on the Padlet once more. Let me X out my double Padlet. And we're gonna be on column number. Give me a sec as I look at the number. Column number, the thing is in my way, 5. Similarities and differences. This is on a document. So let me open this in a new window and let me share the document in the chat just to make sure that everyone's able to view the big document. And then I'll talk about what's in this document so that y'all can do the activity. So the document is in the chat while it's loading over here in my end. Loading, loading. So once you look through, there are 2 student samples. One of them is up here, student number 1. The second student, you got to scroll down. Student number 2. So student 1, student 2. You're all going to go on this document. So there's someone here. Shannon's on the document. You want to make sure you open up your copy because once you're done analyzing what these 2 different students did, you're going to go onto the Padlet on column number 5. And you're going to just jot down what's similar and what's different about the approaches, the answers, or the way that these students got their ultimate estimation for the area. So we're going to be on column number 5 after you analyze that document that I just shared with you. All right, I put the directions in the chat, so let's have 2 to 3 minutes on here to give you some time to process and to write down what's similar or different. The document is linked in the chat. And I see 3 people on this document. You want to make sure you're on this document so that you can actually open it and scroll through so that you can see what's similar or different. Yay, I'm seeing more of us on this document. The website set a timer and I realized that we just have a minute. So feel free to put down your thoughts, and what we could do is analyze this in our next class to see what you all thought was similar or different. And then we could dig into the approaches that each of these students did for this problem. Let me stop this time. Oh, can I get the Padlet link? And this is for window number 5. Window number 5. It's right here too. If you take a look at the student number 1, put window number 5 right here. So for both of these, it's for window number 5. All right, everyone. It looks like we're nearing the end. So what we can do is let's make this our checkout. You definitely want to make sure that you open up this document, put down what's similar and different. And what we're going to do is for next class, we're going to open it up and take a look and see what's similar or different between the two. I'm going to have to let you go since it's it. But yeah, I'll see you all next week. Bye. Bye, y'all. Great class today. See ya. Bye. Bye, y'all.